Hi, welcome to Dissolve Chemistry. Dear students, in the previous videos, we have discussed regarding thermodynamics. Almost 21 videos are available in YouTube. So please make utilization of those. And in this particular video, we are going to start a new topic, that is equilibrium, which is one of the important topic in class 11th. So we will talk about that. Okay. Prior to starting with this equilibrium, let us put some foundation for this. If you put that particular foundation or some of the aspect, if you know very clearly, so then it will be very easy to build the topics of equilibrium. So therefore, let us start with some foundational aspect. Okay. Well, now you assume yourself as a chemist, okay, and you are in the laboratory and you want to perform a particular reaction. You want to bring a reaction between A and B. Okay. So now, if you want to bring a reaction between A plus B and you want to make something C, okay, right? So three important concerns we have to address prior to going through this particular reaction. So first thing is, so we have to know the feasibility, either the reaction what we have designed, okay, feasible or not. Okay, either this reaction between A and B are going to occur in a given conditions, or what type of conditions I have to maintain to bring that particular reaction. Okay, so that we call it as what? Feasibility. Second one is, if the reaction is feasible, then with what rate it is going to occur. Okay, so with what speed the reaction will occur under the given conditions. Conditions we are fitting with the feasibility. So then after that, with what rate it is going to occur. So that is the second concern what we have to address. Okay, and the third concern that we have to address prior to planning for a reaction is that the given reaction, either it goes to the completion or not. Okay, or to what extent reaction occurs. So that is the third concern which we are supposed to answer. Now, the regarding feasibility, either the reaction occurs or not occurs in the given conditions, or what type of conditions to be maintained to bring that particular reaction, all that we are going to address in thermodynamics. About this thermodynamics, already 21 videos are available, okay, which is in concern with the, or as accordingly as with your class 11 syllabus. So please go through those videos to know about the thermodynamics. Then second concern, that is rate. So regarding this rate of the reaction, so we are going to study as chemical kinetics. Okay, so kinetics study will give you the information regarding how the rates of the reactions are going to vary, or what conditions are governing this rate of reaction, and all that. You are going to study this kinetics, and it is in class 12 and you will be studying that one. Then last concern that we have to address is, a given reaction what we have planned, either it goes to the completion or not, or to what extent this particular reaction occurs. So that is being addressed by what? That topic we call it as what? Equilibrium. Okay, so these are the very important these three are the very important topics of your physical chemistry. Okay, exam point of view, as well as to understand many aspects of the chemistry, we must be aware of these three concepts. Okay, so this is what we will be worried more about this particular aspect in the upcoming videos, so that we are going to study as equilibrium. Okay, prior to going for the concepts of equilibrium, what equilibrium means and all that, we must know few aspects. Okay, so prior to that, well, we will talk about types of reaction. As per our requirement in the equilibrium, we are going to categorize all the reactions into two classes. One we call it as what? Reversible reactions. Reversible reactions, and another one is called as irreversible reactions. Word itself is giving some meaning. Irreversible reaction, or you can call it as process. It will not be always a reaction. Even some physical process may be there. okay, process we can add up. Okay, why I'm using these two terms, you will come to know that one later. Okay, well, so reversible reaction or process meaning is what? Okay, suppose you consider a reaction as you have taken as an example. Now, A combines with B to form C. Okay, and after certain conversion of A plus B to C, then what happens? C also develops a tendency to get convert back to the reactants A and B, or it decomposes or it reacts back to give A plus B once again. Okay, after formation of C, or the C, if you directly start with the C, so then C will be having tendency to form A plus B. Okay, A plus B have the tendency to form C. C is having tendency to again react back to give A plus B. So then such reactions where tendency to go in either direction is there, then those reactions we call it as what? Reversible reactions, and they are represented by these arrow marks with hook arrow marks. Okay, we call these as hook arrow marks. Okay, so by that we are going to represent these. Okay, we will take the example for this, and there are some conditions where we can find that a reaction to be reversible, we have to maintain certain conditions. That also will come back. The next is irreversible reaction. Means the reaction occurs in a single direction. A plus B combines to give C, but C is not having any tendency to combine back and form what? AB. Okay, so then such reactions we call it as what? Irreversible reactions. Okay, I will give some of the examples for that. Okay, and it is represented by arrow mark in a single direction, that is towards product we call. Okay, we will use arrow mark heading from the reactants and pointing towards the product. So that is how we are going to represent irreversible reactions. Okay, so now example for this irreversible reaction we can take. Okay, why I have not given example for reversible? Anyhow, we are going to discuss this in greater detail. So therefore, I will take it later. So well, so you take neutralization reaction between acid and base. Simple reaction you can take. HCl plus NaOH. Okay, both in aqueous medium you are taking. So then what happens? It will give NaCl aqueous plus water, which we call it as what? Reaction, neutralization reaction. So it is in a single direction, you cannot get it back, and at any moment we cannot reverse it. So therefore such reactions we call it as what? Irreversible reactions. Okay, now you take, so you are evaporating water, right? You take it in an open vessel and you are boiling that water. Water vapors will escape out, okay, to the into the surrounding. So then it is a irreversible process. Okay, same thing can be reversed. Okay, so that we can do that in a different conditions. If you keep it in open vessel, so that will be irreversible. We cannot condense it back because water vapors are escaping or spreading into large space. So because of that reason, it's not possible to get it back. So therefore, we can take it as evaporation of water. Okay, river or pond or water sources. Okay, so from there. Okay, so this is all about irreversible reaction. Yes, what is the condition for reversibility? If you want to bring a reaction in a reverse direction, at least what we have to do is we have to carry out those reactions in a closed vessel. Reaction or any process you can consider. Okay, suppose you are doing, you want to see the equilibrium between liquid water and water vapors. So then you have to carry out that in a closed vessel. If you keep it open, so that your equilibrium will shift in a particular direction, there will be only evaporation of water is going to take place. Okay, in the reverse direction, it will be in very smaller quantity, rate will not become equal in any condition. So therefore, there is an evaporation of water continuously going to happen. Okay, so therefore, very important condition for to bring the reversible reaction is it should be carried out in a closed vessel. Okay, you should remember that. Right, that is all about reversible reactions. I will give some of the examples. Very important. Okay, you are going to study this also. We call it as what? Manufacturing of ammonia by Haber's process. It is one of the very important example for your what? Reversible reaction. Okay, so manufacturing of ammonia, it's a reversible reaction, exothermic, and many more are there that we will discuss later. And another important example is formation of hydrogen iodide. You can take, okay, 2 moles of hydrogen iodide is formed by the combination of S2 gas plus I2 gas. It is also going to combine reversibly and forms and establishes an what equilibrium we call. So that equilibrium we are going to define very soon. Okay, so these are all called as reversible reactions. Already how I have shown, please make note of this. Okay, you have to use hooked arrows in opposite direction, whereas the irreversible reactions are shown in a particular direction with a single arrow mark heading towards what product and initiating from the reactant. Fine. Reversible reactions or reversible processes are going to attain an equilibrium. Because of that reason, these reversible reaction you should remember, or you should make note of this. Okay, so let us move on to the next. So with this foundation, I believe that now you are ready to go for equilibrium. What equilibrium means. Okay, so let us understand, then later we will define that one. Okay, so first you take A plus B is combining to form C plus D, right? For understanding purpose, we will take 100 molecules of A and 100 molecules of B are taken. Okay, and initially you take time t here, it is 0 second we call, or 0 minute we will take. Okay, second means you cannot make out of it. We will take it as minutes, no problem. So at the first minute, still reaction has not commenced. Then what is the amount of your product? 0, 0. Okay. So now you started your reaction and you checked at the interval of 5 minutes. Okay. After 5 minutes, what you did, you stopped the reaction and you checked that how much amount of the A and B are being consumed or reacted to give the product under given conditions. Right. So there you found that 10 molecules are appearing as product. Here 10A, 10B combined to form 10 molecules of C and D. You should look into the stoichiometric coefficient 1:1:1:1. Okay, so therefore 10 we will get, and I left it another for 5 minutes. Later at the interval of 10 minutes, I checked and it was found to be 80, 20, 20. We get the product. Okay, so then after 15 minutes interval, so once again I checked and it was found to be 70, 70, 30, 30. Right, and then what I did, I allowed that to go for another 5 minutes, and then once again I checked. Okay, 20 minutes. Then it was found to be 60, 60, and here we will get 40 each. Okay, so this is an hypothetical example. You make sure that these values I have taken purposely to make you to understand what do you mean by this equilibrium. Okay, so therefore make note of these things. Well, after this 20 minutes, once again I checked at 25 minutes, and I found that surprisingly, so my reactants concentration and product concentration is remaining the same what it was found at 20th minute. Okay, then once again what I did, after 30 minutes, I waited for another 5 minutes. Once again I checked. Okay, at 30th minute, once again when I checked again, to my surprise, it was found to be 60, 40, 40. Okay, I thought that I should leave it for another half an hour. I left another half an hour. Once again I checked, and again I found the same concentration was maintained when I was maintaining the same conditions of the reactions. Then what it implies? Okay, there must be something is happening. Okay, in either direction. Because of that reason only what it is happening. So the concentration of the reactants and products are remaining same. What would have happened in the reaction, that we will see. See here, A plus B combines and forms, say for example, first 10 molecules will form. Right? initially at what rate it is happening? See here, per minute we will take. Per minute A and B, assume that they are converting two molecules of each. Two molecules of A and B are combining to give C plus D per minute. We will write per minute. What is the rate? Two molecules per minute are combining. Two of A, two of B are combining to give 2C, 2D. Okay. So now, at the beginning only 10 molecules are there. Then there is no tendency to C plus D to combine back and form the A and B. So therefore initially nothing has happened. After that what happens? Still time goes, progresses, it continues to be two molecules each. And later what happens? Slowly per minute one molecule starts combining back to give one molecule per minute. Okay, C plus D will combine and give it back to A plus B once again. Okay, it starts doing that. So when I reach the time like 25 minutes or 20 minutes, then what I found is that two molecules of C plus D per minute are combining to give back A plus D, whereas A plus B are also combining with the same rate, that is 2 molecules per minute into C plus D. Then what happens to your net concentration of the reactants and products? It will not change. What is the reason for that? The number of molecules of reactants combining to give the product in a 1 minute of time and number of molecules combining back from the product to give back to the reactant, okay, in 1 minute are same. So then net change in the concentration will be what? No change, zero change will be there. Okay, it remains what it has been, attaining those two rates equal when it becomes. After that, there is no change in the concentration of the reactants and products is observed. Okay, and that particular point where there is no net change in the concentration of the reactants and products with the time, that we call it as what? State of equilibrium. Okay, so that is called as state of equilibrium. Right? So let us define that one. I think you have understood, okay, the example. So we will define now. In a reversible reaction, or you can take it as process, reaction or process, okay, where rate of conversion, okay, in both backward, first we'll let forward and backward direction is equal, then it is called a state of equilibrium. Okay, so in a reaction or any process, even physical processes also you can take, where rate of conversion, okay, in both forward and backward direction, if it becomes equal, then we call it as what? It is in a state of equilibrium. Okay, so there is what? Rate of conversion in both the direction becomes equal. When it becomes equal, okay, and another condition you should remember, a reaction or process should be what? It should be reversible. That you should remember that. A reversible process or reaction, okay, we will add this one. Right? In a reversible, we must add this word because it is very important. In a reversible reaction or process, where rate of conversion in both forward and backward direction, if it becomes equal, then we call it as what? That process or that reaction is in the state of equilibrium. Okay, I hope you have understood. So now we will categorize these equilibrium into different types to make our study very easy. Okay, so let us classify these. Okay, equilibrium we are going to classify Okay, into three classes to make our study very easy. Okay, one is we call it as what? Physical equilibrium. And second one we call it as chemical. And third one we will take it as what? Ionic equilibrium. Okay. Physical equilibrium, you can take example as the equilibrium between liquid and vapor phase, or chemical equilibrium, many reactions. Already we have seen Haber's process of manufacturing ammonia. So that is a chemical equilibrium. Ionic equilibrium, you can take a dissociation of weak acid as in one of the example. Okay. So we will go in detail with all these equilibrium in upcoming videos. Till then, take care. Bye.